I will be giving a webinar on our soon coming release of SAM. There is a beta release of this version of SAM available on the SAM website, and we anticipate the final release early next week. This version is a major update to the SAM software product that is rebuilt from the ground up, and it adds several new capabilities, including a completely revamped and significantly simplified UI, user interface, parallel processing capabilities, a new, more powerful scripting language and engine, and a new SAM project file format that reduces project size, among other features. So today's webinar is just going to give a high-level overview of some of the new features and workflow changes to help the transition to this version from previous versions of SAM. Before starting the webinar in earnest, I just want to remind everyone that this webinar is being recorded, and the recording will be posted online. And if you have questions as we go through the webinar, you can type those into the chat window, and they can be answered by chat at that time, or we will also leave time at the end for a Q&A session. So without further ado, let me get started. The first feature that I want to demonstrate is actually the new registration process. You will be prompted to register when you first open this new version of SAM, but there is also a registration button in the lower left-hand side of the screen. This registration process is simplified from previous versions. You no longer have to register on the SAM website. Instead, you register by entering a valid email address in this email field and clicking register. In addition to the new registration process, starting with this version of SAM, we will be collecting limited information about the usage of SAM, including your computer's public IP address and how many times you start SAM. Collecting this data helps NREL demonstrate SAM's value to the U.S. Department of Energy and other sponsors who fund its development, making it possible for us to continue to provide this software for free. When you hit register with the email address, you will be emailed a key that goes into this field here, and then you can hit confirm, and that will register your copy of SAM, and you shouldn't have to do any more with that. The next thing that I'll go into is just starting a new project. One moment, please. Paul, can you hear me?
Yep, I can hear you.
Okay.
Let's see, if anyone else is having trouble hearing Janine, please let us know by chat. I guess I'll have to type that in. I'll try to deal with that.
Okay. Thanks for letting us know, everyone. Paul will get working so that anyone who can't hear can hear soon, and I will go ahead and continue. So when you start a new project, you can use this button here, and you'll notice that you're asked to choose a technology and then a financial model, much like in previous versions of SAM. You'll see that this pane looks a little different from previous versions, but it contains the same technologies as in older versions of SAM. Where it does start to get a little bit different is in the financing options. You'll notice that we've added a no financial model option for situations in which you are just looking at the performance or you're not quite ready to look at financial aspects yet. And we have also removed the redundant commercial, PPA, and independent power producer financial models. We've replaced them with the more representative single owner model, which is now the only option for modeling PPA projects, power purchase agreement projects, with a single owner. I'll also mention now that we are researching a new residential leasing model that we hope to release later in 2015. So we will have another financing model available within SAM. So for the purposes of demonstration, I'm just going to go ahead and start with a single owner photovoltaic model, but I'm going to go through several features that apply across all of the technologies and all of the financing options. To start with, I want to go through the new results browser, because that's where all of the information comes from. So you'll see when you hit simulate down here, this is the new look of the summary page. It has the same metrics table as in previous versions of SAM and a host of plots that you can look at, but with a few different features than previously. Another interesting thing to note about the new summary page is that, say you're more interested in this energy loss plot down here and you wish it were further up, you can now drag and drop plots into different places on the screen. I'll also mention on this page that we have some new financial metrics for financial models that include a power purchase agreement. This power purchase agreement price, year one, was listed as the PPA price in previous versions. The levelized cost of energy down here is now based only on project costs after taxes and incentives, but without the developer's return on interest. So that is a different definition than in previous versions of SAM. This new metric, the levelized PPA price, accounts for both costs. This is consistent with what was labeled the levelized cost of energy in previous versions of SAM. So that's an important point to notice. But all of the metrics that you are used to and love are still available, as well as a couple other hopefully interesting ones. The new results browser, you get to the different sections by browsing through these tabs on the top here. And for the PV models only, the next tab is the losses tab, and it gives this loss diagram here showing the energy that you start with and what percentages of it are lost to various things. We hope to add this loss diagram for the rest of the technologies in upcoming versions of SAM. As we continue over the tabs on the top, you'll get to the Graphs tab, and you'll notice it's blank when you first get there. This is the tab where you can create your own graphs. You hit this Create Graph button, and I'll go ahead and select an hourly metric. And one thing to notice is that when you do select hourly metrics, this having it be a bar plot is not able to be rendered on your screen because there are so many bars. So you have to change it over to a line plot for the data to show up. But once you've done that, you can resize this plot. You can add a title, labels, you can change the size of the font, you can add a legend, and you can change the grids. So there's a lot of customizability with these graphs, and you can create multiple graphs on the same page. The other thing that I'll point out about these graphs is that with any graph within this new version of SAM, you can right-click on the graph, and you are able to copy the data, the underlying data of the graph in various formats, or you can copy or export the image itself in various formats. Continuing along in the results browser, the next tab is the Data tab. This is the standard tabular data browser from before, where you can look at single values, monthly data, annual data, or hourly data. And it will just show up in a table there. And you can copy these values to your clipboard to paste them into another program. You can save them as a CSV or send them to Excel. So there are lots of different ways to take the outputs of SAM and get them into the format that you might need them in. The next tab I'll point out is the cash flow tab. We reorganized the cash flows for the residential, commercial, and single owner models, and we've changed the labeling in the cash flows to better match basic pro forma cash flow models that our users are likely to see. We plan to rework the cash flow for the other financial models later in 2015. So you'll see here that it gives fairly detailed information about the cash flow for your project. And the other interesting thing in this tab that I'd like to point out are these buttons up here. So much like with the other results tabs, you can copy the information, save it as a CSV, send to Excel. But what you can do with this cash flow is you can send it to Excel with the equations. So I'll go ahead and hit that button, and it actually opens up Microsoft Excel, which, there we go. And when you send to Excel with the equations, when you click on a tab, you'll actually get to see where that comes from in other cells. So this send to Excel feature includes the formulas and replicates SAM's financial model so that you can trace through the calculations. And we provide these workbooks in an effort to make the financial models transparent for users. So going back to the SAM application itself, the next tab in the results browser is this time series tab. This is an easy way to graphically browse the outputs of SAM. You can select multiple outputs to go on the same graph. You can zoom in on a section of the graph to look in more detail at what's going on. And this is a good way to get a quick look at what's happening in your system with the outputs. The next tab, the daily tab, does a similar thing but goes through the daily averages for the same variables. In the next tab, Profiles, this gives you what that variable looks like on the average in each month. So you can overlay different variables on the same graph and see how they're related. I'll point out that some outputs are grayed out and you can't select them depending on what is already selected in your current plot, because we can only have so many axes in each plot. The next tab, the Statistics tab, gives you basically all of the statistical information you could ever want about many or all of the output variables. It gives you means, sums, standard deviations, daily minimums, daily maximums for a whole variety of variables. So that is another way to look quickly at the statistical output of your simulation. The next tab, which is a team favorite, is the heat map. This shows you the concentration of the output by the month of the year and the hour of the day. So you can get a good idea of when the highest outputs are happening for your system for a whole variety, again, for all of these metrics listed here. The next one, the scatter plot, helps you determine the relationship between two variables. So in this plot, in the left-hand column, you select a metric for the x-axis, and in the right-hand column, you select a metric for the y-axis. So you can see in this case, our default configuration, the hourly energy is somewhat correlated with the global horizontal irradiance. But if I were to pick wind speed, you can see that that doesn't really correlate with the hourly energy. So it's a quick way to look at how your inputs and outputs between each other are related. The next tab is our probability distribution functions and cumulative distribution functions. I won't go too much in detail with those because I'm sure you're all familiar with what they are. But I will point out that you can look at either one individually. You can select the number of bins that you want to look at. You can exclude the zero values and more. So there are actually a few more tabs here that because of the size of my screen you can't see, and that's what this ... button here does. So when I click on that, you can see that there are 2 more tabs. The next one being the duration curve, showing the hours equaled or exceeded by the variable on the left there. And then the last tab is Messages tab. Now for this particular case, it's not a very interesting message tab because there were no errors, no warnings, and no notices, which although it might be boring, is probably fairly good for this simulation. But this is where if your simulation came back with warnings or notices, this is where they're all written out and summarized for you to take a look at in detail if you wish to. And I'll also point out at this time that we do have the 3 different levels in descending order of, I'll say, importance. Errors actually stop the simulation. The simulation cannot continue if there is an error. Warnings are something that you'll probably want to check out because one of the algorithms in SAM found something unexpected and it could still run, but it will give you a warning to tell you that that's true. And notices are more informational and may not be something that you're concerned about. These 2, errors and warnings, will also pop up a message box, as we will see later. So the last thing to view results that I want to go through is I'll show you the reports feature. You'll see that up here, my case is not named at the moment, but next to that case is this arrow, which gets you to a drop-down case menu. This is where you can rename your case, change the models, reset inputs, etc. And you'll see here the second option is to create a report. And that will go ahead and pop up a PDF document, much like this one. You'll see the first page, it goes through what the various inputs were for your simulation. The next page, it provides some graphs of some of the outputs. And the last page for PV, it gives the loss diagram. So that can be a handy way to quickly summarize the simulation you just performed and share it with others. So now that I've finished going through the various ways you can browse the outputs of simulations, I want to go through some of the cooler features that we have in this version of SAM. Some of them were in previous versions of SAM, but we have moved them to new spots to make them a little bit easier to find. And in some cases, those features have been redone a little bit to make them easier to use. So the first one I'll start with is parametrics, which you'll see down here below the Simulate button. You can click on parametrics, and that will bring you to this relatively simple screen. Now, there are 2 ways you can set up a parametric simulation. With the first, you select inputs that you want to vary, the output that you're interested in affecting, and then you'll hit Run Simulations. So because we're in a PV example at the moment, let me use an example that you have, let's say, 3 buildings, and you want to check and see which building is best suited for a photovoltaic system. And the buildings all have different roof tilts and different azimuths. And you'll notice that I didn't know where these variables were in this tree right here, but I used the search box on top to find them and selected them both. So I'll go ahead and hit OK, and it gives me both of those options as columns. Then I'll select the output I'm interested in, and I'm going to want the highest annual energy out of my system. So I'll go ahead and select the annual energy. You can tell that it's an output because it's grayed out and you can't enter anything in there. And I'll also select the number of runs that I want to make. So in this case, because I said I had 3 buildings that I was looking at, I'll put 3. And you can edit directly in this table the values that you want. So let's just say that I have buildings at these 3 azimuths, and at each of those buildings is at a different tilt. So lastly, you'll go ahead and hit Run Simulations. And you'll notice that it gives you the annual energy within the table. It fills it in. And it also shows you this graph of what has the highest energy. But now let's say that there's an option to buy a racking system, and you can have any of these three buildings at any angle between 20 and 40 degrees. That's a lot more combinations you have to look at. So in that case, I would use the other way to set up parametrics, which is this quick setup right here. So when you hit the quick setup, it brings you to a screen that's similar to how parametrics worked in previous versions of SAM, where you will select variables to add. And now that I know that both of those variables are in PV system design, I'll just go ahead and find them. And then you highlight a variable that you've added and select the values for it. So for this one, because I have the three different buildings, I'll go ahead and remove that default value, and I will add the same azimuths that I had before. Okay. And then for the tilt, I said that we can do anything between 20 and 40 degrees. So I'm going to use this define range over here, starting at 20, ending at 40, and let's say it goes in 5-degree increments. When I hit update, it will automatically fill those in, and I can hit OK. And you'll notice that it asks me if it's OK to overwrite the table, which is fine with me. And it will create all of those 15 permutations that I described, but in an easier way than actually specifying 15 runs and filling it in myself. So I'll go ahead and run simulations again. And now it gives me a lot more information about what the output is for each run. And again, the graph is an easy way to sort of pinpoint which one's the highest or the lowest or whatever it is that you're looking for with the parametric simulation. So this is a very simplistic example of a parametric analysis, but there is going to be an entire webinar in January dedicated to parametric and other statistical analyses. So please sign up if you're interested in learning more about performing these analyses in SAM. The next cool feature that I'm going to demonstrate in SAM is this P50, P90 capability. So this is to compute probabilities of exceedance given a whole batch of weather files. So what I have done is I have already downloaded a long-term historical weather data set for Phoenix, Arizona. And links to that long-term historical data set for various locations are available on the SAM website. But what I want to do now is I want to direct SAM to the folder in which I have all of those weather data files. So you can type the name of the folder into this box here, or you can hit this, again, ... and it will pop up a folder browser. So I'll go ahead and select this folder that I've already downloaded, and it contains 30 years of data from different years for Phoenix. So I'll go ahead and then run the P50, P90 analysis. And here you'll see that parallel processing that I was talking about earlier. And this is a good opportunity to demonstrate the way that notices and simulations warnings are handled. So you'll see that this is issued as a notice that you're in 1990 at midnight at the end of the year, the irradiance was 9,000 watts per meter squared, not a realistic value. But you'll see that SAM has taken care of that by setting it to 0, and that's why it's issued as a notice. It's also not a big deal, being 1 hour out of 30 years of data, so I'm not so concerned. But I do know where it is now if I did want to go fix that within the weather files themselves. So I'm going to hit continue to ignore that for now. And you'll see that these are the P50, P90, and other statistics that SAM calculates for all of these different metrics. I will mention here that SAM calculates P50 and P90 statistics First, assuming an empirically determined distribution, and secondly, using a normal distribution, which is why there is a P50 and a P50-norm on this page. But this gives you a whole lot of information about probabilities of exceedance for all of these different metrics. The next functionality that I'm going to demonstrate is this macros functionality. And this is a brand new functionality in SAM. It uses a scripting language called LK, which is the new scripting language for this version of SAM Forward, replacing SAMUL. LK is faster and more powerful, and it allows direct access to the SAM Simulation Core Engine, or SSC. It also has new functions that allow you to plot data, read and write CSV files, and more. And as another plug, we will be giving a webinar that goes more in-depth into the world of scripting of SAM in March. So please sign up for that webinar if you are interested in it. But today, I just wanted to demonstrate scripting as it relates to this macro capability. So I'm in this macro window. The list of macros that are available are here on the left. I'm going to go ahead and select this Create Tornado Chart macro. This particular macro duplicates and replaces the sensitivity analysis capability in previous versions of SAM with an easier-to-use functionality. The way that all macros are set up is that the inputs are over here on the right-hand side, and on the left is a set of instructions for how to use the macro. So I'm going to go ahead and demonstrate it. I'm going to select some inputs to look at the sensitivity to. And let's say I'm not too certain about some of the interest rates for my project. So I'll go ahead and select the construction loan 1 interest rate and my interest on reserve. Now, in most cases, in the macros, any input that isn't specifically specified here is going to use whatever is already specified in the case that you're looking at, just as a clarification. I'm also going to select the output metric that I'm concerned about these interest rates having an effect on. And let's say that that's the LCOE, levelized cost of energy. And I'll leave it that each of these interest rates could vary by plus or minus 10%. You can adjust this to apply to all of the variables that you've input, or you can adjust them individually if you wish by highlighting the input in the list and selecting Edit. But I'm just going to leave it at the default for now. Now that I've set up all of the inputs, I'm going to go ahead and hit this Run Macro button. And you'll see that it pops up this tornado chart. Now this is sort of a simplistic example. Obviously, lower interest rates will result in a lower levelized cost of energy. But this showcases, A, that this sensitivity analysis capability is now a macro. B, what type of thing you can do with macros. And C, some of the new capabilities of the LK scripting language, including plots. The last thing I'll point out with macros is this View Code button here. So this will pull up the code of the macro itself written in LK, which I won't spend too much time on, except I will point out that this means that you can edit the functionality of a macro yourself, and also that macros present an easy way to share scripts with non-programmers. You can create your own macros, which will show up in this list, and all you have to do to make a macro show up in this list on someone's computer is to place the script file, the .lk file that will be created, in the appropriate folder on their computer, and it will show up in their version of SAM. So this is a great way for, say, a company-wide post-processing algorithm or something you always want to look at to be shared consistently amongst people. So now that I've run through some of the cool features that apply to all technologies, I'm going to take a few minutes and run through some of the new features or specific updates for specific technologies. I'll start with flat plate PV, then I'll do wind really quickly, and finally point out a few new features in the CSP power tower model. So let me go ahead and create a new photovoltaic residential case to point out a few of the new features here. The first thing I'll point out is the format of the resource page. And even though I just said that this was going to be specific to PV, this is actually going to be the format for the resource page in most technologies in SAM, not just PV. So you have what boils down to 3 options for how to get your resource file. You can choose a file from the library, much as you could in previous versions of SAM. Although SAM is now shipped with more weather files than it used to be, thanks to the new SAM CSV weather file format that allows these files to be smaller. If you don't want to pick one from the library, or the library doesn't have an appropriate location, you can also download a weather file. In the case of solar, you download it from the NREL Solar Prospector. And in the case of wind, there is another resource that you can download them from that I'll show you in a little bit. But if neither of these works for you, you can also, or you have your own weather file, you can also select to use a specific weather file by clicking this button. And then you just direct SAM to the weather file on File. Next, I'll go really quickly to the module page. This is more or less the same as it has been in previous versions of SAM, with a library that you can select one from. But I will point out the new way to change between models in SAM is this drop-down menu. So anytime you see a blue menu like this at the top of your input page, there will be different model options underneath it that you can select. I'll skip over the inverter page because that hasn't really changed and go to the system design page. This also looks much the same as the array page in previous versions of SAM, but you'll notice that the subarrays have now been migrated onto this page as well. So this is part of a larger effort to redesign the user interface for solar to make it more intuitive and easier to find the inputs that you're looking for. So you'll see that all of the system design parameters are now located on the same page. And we have a few new pages, namely shading and losses. So this shading page now contains all of the shading options that we have in SAM. And I'll point out that the 3D shading calculator has been fully integrated into SAM now. So you can open the shading calculator by hitting this button. You can create a 3D scene, and then it will automatically apply the shading values to this project. I won't go into detail on the 3D shading calculator. If you need a reference on that, we did a webinar in the spring, and that's a great reference for how to use the 3D shade calculator. There are 2 other options for how to model shading in your system. First, I'll point out that for each subarray, you can import shading files created by PVSys, by the SunEye tool, or by the Solar Pathfinder. And lastly, there is an option to model self-shading for your system. So you go ahead and you can say that there's no self-shading in your system, or that your system is self-shaded. And the self-shading can now be applied independently to all 4 subarrays, where previously it could only be applied to the first subarray. There is a consistent self-shading model in use between fixed and one-axis tracking systems. Before, they were slightly different. And the inputs have been simplified for easier use, making a few assumptions about some common layout characteristics. The next new page, as I mentioned, is the losses page. We've organized all of the losses into the same place in SAM to make them easier to find. And we've also transitioned throughout SAM away from the term derates to the term losses. So for an example, this mismatch loss here is a 2% loss Before, it was a 0.98 D rate. We've done this because it's a more intuitive way to think about losses, and it's also consistent with industry practice. I'll also point out that the curtailment and availability input is on this loss page now as well. The financial pages I'm going to mostly skip over because they've remained largely the same, although they have been cleaned up a little bit. And I'm going to go down to this electric load page. The electric load has 3 options in this, again, model switching drop-down menu. You can select that there's no load for your system. You can select to input the load data yourself, or you can use this load data calculator shown here, which is a new feature for residential systems. The way this calculator works is that you give it inputs about your building, what types of appliances it has, what you keep your temperatures set at, and then you give it monthly load data, so for instance from your utility bill, and it will calculate hourly load profiles to use in the simulation. You can preview those calculated loads by hitting this View Load Data button, and it will show you the hourly electric load that it has computed. So that is an overview of the new functionality in the photovoltaic model. Next, I'll go ahead and I'll move on to a wind model to show a few highlights there. The first thing that I'll mention is, as I showed in the solar model, the resource page, again, has the same 3 options, where you can select from a library, you can download a file, or you can use a file stored on disk. In the wind models, downloading a weather file comes from the new NREL Wind Toolkit for the continental US. So that is a new data set in-house here that we're excited to be able to access. Another new feature is down on the wind farm page, which has been redone somewhat to be a little easier to use. You'll notice that much like the solar system design page, you can now simply specify a desired farm size, and SAM will automatically calculate with the turbine that you've selected how many turbines you use to get approximately to your desired farm size. And it will lay them out in roughly some type of grid. I'll also mention that the units for spacing between turbines have been updated. Previously, this was in the unit of meters, and now it is in the unit of rotor diameters. This means that it will update automatically what the spacing in the farm is if you change to a turbine that has a different rotor diameter, which makes this easier to run in parametrics, or if you simply forget to go back and change the spacing between your turbines when you change turbine type. Moving down to the system costs page, I'll point out that this one has been redone a fairly significant amount, and it integrates this new land-based balance of system cost model. So using these 2 buttons up at the top, you can estimate turbine costs or balance of system costs, and that will pull different models that NREL has developed depending on if it's a land-based or offshore installation and what size your farm is. So if I go ahead and click this Estimate Balance of System Costs, you'll notice that it directs me to these inputs down here, which have now expanded. And it has a host of detailed inputs, so you can get as detailed as you want with this. And it provides you not only a total cost number, but also the detailed breakdown of the cost model. So once you've entered your inputs, you can go ahead and look at your total numbers here and decide if you want to apply it to the costs used in the simulation. And if so, you go ahead and hit Apply, and it will show up in the appropriate box up here. So those are the highlights of the new features in the wind model. And lastly, I'll go ahead and show one of the cool new features in the power tower models. And that is on the Heliostat field layout page. I won't spend too much time on CSP because there is a CSP-specific webinar in February that will go through all of these in more detail. But the biggest new feature here is that we have transitioned away from the previous Heliostat layout algorithm using Del Sol, and we've replaced it with the new NREL Solar Pilot method. So I'll go, and if I change this from 12.2 meters to 20 meters, I can go ahead and hit Layout Heliostat, and it will automatically compute the figurations for me and update them. This has also added support for the relayout of the heliostat field when you're running parametric or stochastic simulations by clicking these buttons. And there's also an optimization algorithm to optimize the layout of your heliostats, which I won't show now because it does take a little while to run. But I believe this just about covers the new features that we wanted to highlight in today's webinar. So I'll go ahead and thank you all for coming. I anticipate that there are several questions, which was why I was sure to leave lots of time for question and answer at the end. Reminder that if you have a question, you can type it into the chat window, and we will go ahead and answer those now. And that this webinar was recorded, and the recording will be posted, so if you thought it was valuable, you can share it with those who were unable to be there today. And any additional questions that you don't want to ask now can be posted on the help forum on the SAM's website, or you can email SAM support. So thanks again, everyone, for your time, and I'll go ahead and open the floor up for questions.
Thank you, Janine. This is Paul Gilman. I also mentioned that if you can figure out how to raise your hand in the little window there, we can use that approach to, if you want to ask your question by voice.
I see a question here that says the variables listed when you browse case inputs don't match the variables listed as required parameters in SSC. I'm assuming you're referring to this inputs browser here. And it does list all of the variables that are inputs in the model, not just the required variables for SSC. So perhaps that's where the confusion is coming from. There certainly are quite a list of variables, especially since I have so many different types of project open at the moment. Does that help at all? Some variables listed as required are not shown. There are some variables in SSC that are required to run a module that are not they're not changeable in the user interface, so they're required basically just from a programming standpoint. So it may be that if you're accessing SSC directly through scripting or something else, that you are running into variables that are not present in the user interface because they're set behind the scenes. So I would recommend that for those particular variables, if you have questions, to contact SAM support.
Make sure you do the SSC dev.
And make sure that you are using SSC dev is a good point. Let's see.
While we wait for more questions, this is Dave Blair, and I would just ask people or let people know that we have made some updates since the last major release to the documentation on the website as well. In addition to making sure that all the YouTube videos are listed and links to how to get started with SAM are there as well. We've updated some of the cost data resources. And maybe most importantly, I think we've created or made public spreadsheet versions of the Excel versions of the complex financial models in SAM. And so you can download those Excel versions. You can also, within SAM, do send to Excel from the cash flow page, but which gets you to basically the same spreadsheet. But we wanted to make sure people were aware that there are some updated resources as well as the spreadsheets available on the website.
All right. And I see a few more questions here. One person who was a little late to join is curious when this new version of SAM is available. The beta version is available now, and the final release is scheduled for next week at this point. And I see another question asking if you can run a simulation using two different types of inverters to sum to a single project. At the moment, the best way to do that in this version of SAM is to create two different cases, and then you will have to post-process the results to sum them. That was a feature that we had in previous versions of SAM, but due to the extensive recoding in this version of SAM, that feature has not been made available in this version yet. However, with the new LK scripting language, it is easier to post-process two cases to add the results together using scripting. I see one question about training sessions for SAM and whether or not we offer them. Paul Gilman, who is on the line as well, has offered training sessions for SAM. Paul, do you want to give a little more detail about that?
Yeah, for now we've been offering these webinars that cover various topics, and in the past we've had training sessions offered in coordination with various conferences, although we don't have any of those scheduled for the future. So we don't really have a training program. We don't offer regular training sessions, but we do have resources available to help people learn the model.
Okay, thanks, Paul. I'm not seeing too many other questions come through. So are there any other questions that someone is dying to ask? Okay. In that case, I think I'll go ahead and wrap up. Thank you all for your time and attention, and I hope that you enjoyed the presentation and that it was helpful.